This is basically just going to be a 101 on really basic, simple steps to sort of start looking at websites and what hackers might try and inject into websites and what information they're trying to get out, essentially. So we'll start with Legend Outcomes website. It's not live, it's all hosted locally, so you can basically do what you like to it, but it will give you the steps against what it would look like if you were actually out in the wild trying to do this stuff. So sort of the main attacks, I don't know if you've seen this before, but this is sort of the OWASP top 10 is what it's named. Project company called OWASP go around to big sort of hacking companies and they go, okay, what's the most common thing you find and what's the most dangerous thing you find on people's websites? And this is sort of the list. So you start off with injection, broken authentication, so now and then you'll find sites where you can just put in a directory and you can go straight to it. So say if it was an administration panel, you'd go their website /administrator or /admin, and it won't ask you for a login and it'll take you straight to their administrator page. It sounds like the simplest thing you could possibly have on a website, but it's number 2. I can speak from experience. You don't necessarily find admin panels because that's what they check, but you find the directories behind the admin panels. So you'll go admin /emails and you might see all the emails that company has sent to every customer from that server. I think something like that. Sensitive data exposure, these two sort of go hand in hand. So if you're sending information via HTTP instead of HTTPS, when it's not encrypted, someone can just look at that and go, okay, I have your email address and your password, or I have your whatever sensitive data is sent over the wire without being encrypted. It was a big issue. Now it's very hard to find a website that doesn't use some form of encryption to send sensitive information. If they are, they shouldn't be doing, because there's literally no excuse. External entity injection, it's a little different. So some sites allow you to upload images called SVGs. And the thing that differentiates an SVG between the rest of an image, like a JPEG or a PNG, is actually code that makes up that image. So it will say, make a line from this point to this point of this color, and then you can fill it in and change that code, and it will change the actual properties of the image. And they're used for, like, if you have a logo that you want to expand really large or make really small. Broken access control, similar to authentication. Again, security misconfigurations. So this is, a lot of them are like, yeah, don't do stupid stuff and double check the work that you've done so it's not insecure. Cross-site scripting, we'll be going over that. We'll be going over injection. We'll be going over some other stuff. Insecure deserialization. So if you're hiding login tokens, so when you make an email and they send you a verification email, that page that they send you to has to be public. And the way that they try and hide that is using some form of serialization. And if you can walk that back, then you can then make view any verify email token that they would send to any person. Instead of just going through them all. So code injection. Code injection, usually sent in a post request. And so the main issue that you find with almost any website, if it's not a misconfiguration, it's you're sending people information which is mixed with data that you need on the website's end. So if I ask you to log in, the user has to input something to log in. So they have to input the email address or the password or whatever 1,000 different pieces of information you might input into a website. And this is where sort of the issues lie, because if you know the back end of a website, or you can guess on what back end features the website will have, so usually it's a database or something like that, you can then try and inject code into that website which will hit the database and then be used or run.
So the post data is, if you've got a login web page, post would be that page sending a request to the second page.
Yeah, so your client browser will send a post request. So you've got post, which is sending something to a website to change something that already exists, or you're telling a website something. And then you've got a get request, which is get me this page if I'm browsing around the website. And usually if you send in a post command, all the data that is sent is in your control, which means that you can edit it and change it and send malicious data to that website. You'd think it'd be a simple thing, but you find that almost any website is vulnerable to some form of, call it command injection. Sometimes it's just a reflected command into the client's browser. So we'll start with SQL injection. The back end, usually, if you're looking at a website, the back end of any website is going to be some form of database, and the language that they use to communicate with this database is called SQL. And if you're sending this malicious data here, you can see, this is just my normal username. But if you come to this bit, that will comment out anything before or after. So this will break out of say if I'm sending you my email address and you have to check it against a database of email addresses, this will comment out of the code that does that. And this will go, or true, so this 1 = 1 always returns true, and then it will comment out the rest of the line. So this breaks out of any back-end code that is containing your email address, and then the rest will actually just say return true. So if I send this, so this one breaks out, so it looks for test at test.com, breaks out, goes or 1 = 1, and then comments out the rest of it, so it doesn't even check for a password. And when you click login, it'll go straight to the database, through the web application, and it will say, yes, it's returned true. This command is true. You can log in. And that's sort of a very simple overview of SQL injection. Cross-site scripting, it's a little easier. So on your browser, you have what's called JavaScript, and that sorts out all the logic of a page. So if you have, you want a box to move around the screen, you do that with JavaScript. And it comes in handy if you're trying to attack a specific set of clients or a specific person. So if you know the British Airways hack that happened recently, what happened there was they had some JavaScript running on that page which was malicious and would just copy any keystrokes that went into that page and send it to their malicious server. So the attacker would be able to capture credit card information, addresses, names, just from I think it was something like 14 lines that they've been able to inject and hide inside of an already existing JavaScript that they were loading onto the page. Almost every page has JavaScript, and it'd be very rare for you to find a page that doesn't. SQL XSS, cross-site scripting, happens when the input is not sanitized correctly when it goes into HTML. So if you think of HTML as the content of the page, if you're not sanitizing this JavaScript, it will, instead of making it look like it's just content that should be on a page, it will run it as though it is an actual script to rerun on the client's browser. There's 3 different kinds. Main one, stored XSS. So if you can get this on a page, stored cross-site scripting, it means that it will load every time that the page is loaded. So this could be, I'm going to change my name on this application to be some JavaScript, and this JavaScript will then run anytime someone sees my name anywhere it is on, wherever it is on the application. So it can be something simple to like bumping your company to the #1 register on a company list, or it could be something that steals the data from whatever client you're talking to. And the way it's usually done is you find a sort of a storage position on the main website. So you'll find a comment box, a review box, a name, and where data is actually stored on the website and then displayed to the user. And this will be run as a script whenever that is displayed or that page is loaded. And you can say, because it's stored in the website, it goes straight to the client, it's run on their client's browser, and their client's browser can then connect back to you, send them what they're doing anything like that. And it's the main issue with this is sanitization. If I give you some malicious code and you're not cleaning it correctly, if you're not removing the stuff that needs to be removed, then it's gonna bite you in the ass at some point, essentially. There's another one, reflected XSS. So usually you'll do this in like a search function. This is when something's taken from a URL or some other user-controlled parameter and is then sent to a normal person. So if I found a search function that in the URL had this cross-site scripting vulnerability, I could send that whole URL to someone, and when they clicked it, it would run the JavaScript on their page when they loaded the website. This only works when you have that interaction with the client, when you can send them this URL and they click it and it loads up that JavaScript on their page, instead of it already being stored there and being used and ran whenever that page is loaded. Third, .xss. So .xss. So it's a little more complex. It's almost always reflected. So you have to have some form of interaction, but it doesn't have to be. And it is all based in the client's browser. So although you might put the page up there, it's not necessarily running JavaScript. It's injecting into the JavaScript on the client's page, which is then run. It takes a couple of examples to sort of understand how it works, and like a spoken example isn't going to help too much. But essentially it's you injecting some payload into the client's JavaScript and into their DOM, which is a document object model, and it's just how websites are formatted in your browser. If you can inject it into their DOM, then you can run that code and it will just run on that page.
How are we doing, Darren? You alright?
Yeah, right?
Alright, on here?
Yeah, I'm like,
Really good. How are we doing, guys? You okay?
yeah.
Yeah, so there's a web server VM on here. if you just put them on the same network as the Kali box. I wouldn't worry, you'll need that up anyway. Yeah, you'll need them both.